When an approach to building control decisions is aligned with the building's purpose, the occupants and building can actively learn and adapt over a building's life cycle. I'm Kalvelage, and I am presenting why a user-centered approach provides a more sustained and holistic solution to building controls. I will first provide an overview of building controls and the motivation behind this research, followed by the problems associated with building controls. Next, I will present my research solution and approach, followed by the expected results and conclusion. A building's purpose is to support users' tasks and activities over an extended period of time, with support from interface interactions, also known as building controls. Building controls are essential to optimizing a building's service, comfort, and safety. Controls can do a number of things to help reduce building energy and improve indoor conditions, including learning and adapting to human behavior. A controlled system is composed of three building control elements: the interaction, location, and setting. The interaction can be modified by three factors of time, condition, and occupancy. Building controls facilitate the interactions between the environment and building and systems, systems and systems, and occupants and systems, and require support from interaction interfaces. These complex interactions produce many challenges associated with designing buildings and systems that stem from the variability and unpredictability of these interactions. We can separate the components and examine them individually. However, these cannot be developed in isolation from the problem domain or from each other if we have any chance of providing a focused, integrated solution. To still account for each of these components, countless comfort and environmental standards have been created to reduce the amount of variability in the component. Aside from creating a standard, the only other solution is to provide local, individualized occupant control. However, occupant control poses a number of problems. Individual control often leads to the detriment of the building environment as a whole, such as increased energy demand and shortened equipment life, such as leaving the lights on and opening windows when the heating and cooling is operating. Therefore, building designers and owners have limited the direct control occupants have in the spaces they occupy, such as fixing windows, putting the shading devices on the exterior, removing control, and implementing a lighting schedule. Without providing the occupant control of the space they occupy, essentially the space is designed for the perfect occupant in a perfect world. Since neither of these exist, no tasks are performed, and now there is no purpose in which to provide a building for in the first place. So we are left wondering, how are decisions made regarding building controls? A great deal of research has been conducted on methods for decision-making regarding building controls. The more common approaches are cause-effect postulates, such as the cost-benefit analysis and economic impact analysis. Operational decisions are based on policy, company standards, or recommended maintenance schedules. Or the more popular stakeholder objectives, such as energy efficiency and financial profit. However, how do you put a price on social and environmental factors? Whose objectives are we designing for? The public? The owner? Employees? And what if there's an objective conflict? How do we decide? So why don't we return back to the purpose of the building, to support users' tasks? And return the control to the one who's doing the task in the space, and provide a method for individual and local occupant control of their environment to put the occupant back in charge of their health, safety, and well-being. Rather than focus solely on a moving target, the user, instead focus on the tasks the user performs, which will reveal a decision-making tool for building control decisions. The built environment utilizes two main theories to explain the influence behind human behavior that produces the user's experience with the building. At one end, we have the environmental deterministic theory. This theory says the physical environment influences behavior. The benefits of this theory are the extensive environmental psychology research that produces meaningful and measurable results. However, these fail to account for the human experience that rarely conforms to the cause-effect precept. This theory also fails to account for social aspects, and there are limitations in self-reporting. At the other end of the built environment theory spectrum is the social constructivism, which says social and biological influences human behavior. The benefits of this theory are that we can draw from learned behavior and cultural and social norms. However, this theory ignores the known fact that the environment has effects on human behavior, and there is little support to substantiate claims. The user-centered theory falls in the middle, gaining benefits of both theories. Applying a user-centered approach to building controls focused on the user's tasks provides a more holistic and sustained solution. To test this theory, I'm proposing a modified interface design in which users input their desires based on their tasks. To design the interface, I will follow 3 steps: elicit the required knowledge, develop the interface, and test the interface. Knowledge for the interface is required from both the building and users. The building provides information from sensors and systems. User knowledge is their desire and task requirements, with a special focus on the imperative and effective information. All of this information will be used as feedback into the building control systems to learn and adapt to the human behavior. Current control interfaces are presented to users in terms of the systems, such as turning the temperature up or down. Rather, I propose in the language of the user, targeting factors that impact task interruption, what does the user want to control, how and why, and what does the user not want to control. That is, what is detrimental to the task if action from the user is required. To test the interface, I have devised scenarios that are representative of typical commercial office environments. The scenarios consist of an existing office environment in which the user will complete a typical office task in one of 2 settings. They will be provided with one of 2 types of controls, and as an experimenter, I have control over the HVAC, exterior views, lighting, and acoustics of the space. It is assumed that all tasks will require certain furniture, equipment, and systems, which will be based on the current building code standard minimums, as well as what's provided in the typical environment today. For the closed office setting, a single occupant office will be constructed providing the following specifications. For the open office setting, an open office environment consisting of low-rise cubicle partitions will be provided with limited control. As a result of this experiment, I expect a number of results. The expected results are fewer interruptions for the user's tasks, and the user will have a greater understanding about the building interaction and the building capability, and the stakeholder objectives will be achieved. In addition to user and stakeholder benefits, the revised building control design has other implications. The system modifications can produce new manufacturing opportunities for systems and alternative methods to achieve a desired condition. This will result in a greater number of options, reducing the cost and potentially further increasing money savings. Building operators will be aided in their decisions regarding new and upgraded equipment as to what will better support users' tasks. In conclusion, applying a user-centered approach to building controls focused on the user's tasks provides a more holistic and sustained solution. This is an innovative approach to the design, selection, and operation of the building control systems. The user-building interaction is a continuous process of transformation that, when effectively captured, can be reapplied over the course of a building, allowing a building to learn and adapt to support users' tasks and activities. Thank you for your time. This concludes my presentation, and you may email me with any questions.